Bismillahirrahmanirrahim. Assalamualaikum dear students. I am Mr. Kadim Khan and I am a lecturer in the Institute of Computing, Quart University of Science and Technology. Today we will take lecture number 15 of the subject of Object-Oriented Analysis and Design, in which we will discuss the class diagram, which is the structure model of the project through the UML. Dear students, in every object-oriented programming language such as Java and C++, the class is an essential element which contains the data member and member function. The member function processes the data members and generates some useful results. So to model the object-oriented programming language project, we must have to design the class diagram. So class diagram represents the model of the project which is implemented through the object-oriented programming languages like Java and C++. This is the discussion agenda of our today's class. We will discuss UML class diagram, domain model class diagram, and the system model class diagram. These are two different types of class diagrams. Then we have the UML class notations, in which we have the binary association, unary association, aggregation, and compositions. Then we have the inheritance, which is also called the generalizations, the UML multiplicities, and the UML class diagram examples. Now, what is a class diagram? Basically, class diagram is a main building blocks of every object-oriented methods. Like in Java, C++, and in Python, the class diagram represents an element of the programming language which encapsulates the data member and member function inside of it. Now the class diagram shows the classes, relationships, interface, associations, and the collaborations. We have the classes in the class diagram. In fact, there can be one class and then can be multiple classes. And then we have the relationships among the class diagrams. And then we have the interface class diagrams. In the class diagram, interfaces are special types of classes. And then we have the association. Association means one class associate or link with the other class using objects. And then we have the collaborations. Collaboration means that some classes share data member and member functions. Then they will cooperate with each other, like interface class shares its functions to another concrete class. Now classes are the main element in the object-oriented programming languages. So the class diagrams has appropriate structure to represent the classes, inheritance, relationships, and everything that OOPs have in its own context. So the class diagram is a very much important element of the OOPs programming language. Now class diagrams contains the classifiers. Classifiers are called classes and interfaces. So every class diagrams contains multiple sort of the classes and interface classes. So class diagram shows different classifiers of the systems. Subsystems are the components which has certain relationship among the classifiers and also having their attributes, operation, and constraints. The attributes means that different sort of the data residing inside of the class, and operations are multiple services or functions that are implemented in the class, and constraints are certain conditions which are imposed on the classes. For example, we can access the parent class but we cannot access another classes. Then we will declare such a class as a protected, or public or private. For example, if we declare a class private, we cannot access it outside of the class. If it is a public, we can access this class everywhere in our programming code. Now, some common types of class diagrams are called domain model class diagram and the system model diagram for the implementation of the classes. Now we will discuss each and every one in the detail. The domain model class diagram, as its name depicts, represents the area or the domain of the project. Here we just provides the names of the class with their different attributes list, but we do not provide any sort of the operation list here or the function list. So just we provide the main classes and another classes and their associated attributes, and also we provide the different relationships among the classes. For example, this is the example of the book system or library management system. Here this diagram doesn't depict any sort of the operations, but just it shows that what sort of the informations are residing in different classes. For example, we have the book class here, ISBN, which is a strings and containing 0 or multiple instances, and it is in an integer. Similarly, we have the title, which is just strings, summary, publisher, publication date, and number of pages and languages. So these are different sort of the attributes list. This is the abstracts class. Then we have another class, book item, and here you can see a stereotypes of the entity. This is the entity class. Right. It has the barcode strings 0 to 1, that is 0 instances or multiple instances, and it's is of the integer data. And tag RFID 0 to 1 instances, and it's also of the integer data, is reference only. This is another attribute. Okay, this is a stereotype class, and it is the entity class. Here you can see there is no stereotypes, but here it is the entity class. So that means that this is a generalized abstract class, while this one is a special class of the type entity. Now here it is another class, catalogs, but there you can see there is no such informations or data inside of the catalog class. But that means that catalog class will access the book item class, and all books will be in fact added into the catalog class. That means that these information will be automatically inside of the catalog class. That's why we have not declared these data again here. Right. Now you can see there are certain labels like ** and 1. This means that one to many associations, means that this class has only one instance, while this class may be multiple instances. That means that in one catalog multiple book items can be stored. Now this is the association relationship. Dear students, all these relationships we will discuss in a very much detail in the upcoming slides in this lecture. But here association shows that a link or an object instance between these two classes. When the object of this class is declared or accessed here, so automatically all this information will be transferred here. Okay, so for example, if book item object is accessed here or it is instantiated here, so automatically to the object of the book item we can access all these data members inside of the catalog class. Similarly, we have the library class. Library class has a relationship with the account entity class, which has these different sort of the informations. Similarly, we have the author class, which has only name, strings, and biography, which is also a strings. These are the different attributes. And similarly, we have the account states class. Account states class as the active, frozen, or closed accounts. It is an enumeration class. Enumeration means that this well contains enumeration data types, and it is linked with the account class through the uses relationship. The uses relationship means that the presence of this class is very much important for the account class. If this class has been destroyed or deleted, this class will be affected. Similarly, we have the patrons class. Patron class also uses the search class. For example, we will decide the search patterns here. The customers will use certain patterns for the searching. And also we have the library class having the attributes of name, address and position. And it is connected through the uses relationship with the manage class, interface class. This is the interface class with the interface stereotypes. That means that it is an external class, interface class. Another examples are the types of system model diagram of the implementation classes provided here. This is another types of the class diagram of the UML called the system model diagram of the implementation classes. The difference between the domain model and system model is this one, that in the system model we also provides the list of the operations. For example, we must have the attributes list. This is the attributes list, and also the list of the operations. Here you can see this is the Android dot view, and then scope resolution operator and surface holders. This is an interface class of the surface holder, and interface class is accessing the view class, and view class is accessing the Android class. That means that they have certain relations here. And the plus represents that this is the public relation, public access specifier, right? Another is the interface class here, callbacks and surface holders, and also as the scope resolution operators with the dot view and Android. So, and another one is the surface view, and surface view Android dot view dot scope resolution and surface view. Now, preview class is a child of the surface view class. This is the generalization relationship which shows the inheritance, that the preview is the child of the surface view class, and this is the M holder surface holder. This means that this is in attributes members holders, which is instantiated from the surface holder data types. Okay, and then we have certain operations are the functions inside of the previous class. There is the preview, surface change, and similarly we have the plus and slash relationships. We will discuss this relationship in the upcoming slides, but this shows the access specifiers of the data member and member functions. Okay. Now for the public we use the plus relationships, and for the private we use the minus relationship, and for the protected we use the hash relationship, and for the derived we can combine with another relationship, we use the slash relationship, and for the package we use the tilde relationship, and this belongs to the package class. Now UML class diagrams has multiple important relationships or notations. These notations are used to represent or to design the class diagram. A class is a rectangle divided into three parts. First we will specify the class names. The class name should be very much meaningful, that it should represent the types of the class and the purpose of the class. For example, employee is the name of the class. Then we have class attributes, that is data member and variables. In the next section we have certain variables or data members inside of the class, and then we have class operations. Class operations are different functions or the methods inside of the class, which is the last section in the class. Now we have minus for the private. Private means it cannot be accessed outside of the class, and plus for the public. Plus means it can be accessed everywhere in the project, and protected hash means that which is this hash symbol, which means that this attributes can be accessed only in the child class, but it cannot be accessed in the non-child classes. So we can use only the children classes can access the hash symbol. And also we have the statics. Statics are those attributes which are underlined, so it's shared among all members of the classes. The abstract class name is provided into the name is provided in italic fashion, while the concrete class name is provided in the non-italic fashion. Now, class notations has important relationships, that is called association, aggregation, composition, and inheritance. Associations is a relationship between two classes when one class exactly is associated or instantiated through the object with the other class. So where one class must know about the other class work. So that is called the association. For example, client communicate to the server. For communicating the clients towards the server object will be accessed inside of the client, and through the object of the server we accesses different function in this implemented in the servers and it is accessed, all these functions are accessed in the client, and it is indicated by the straight lines or the arrow lines. Aggregation relationships are the relationship where one class belongs to a collection. For example, instructor part of the faculty. Instructor is the part of the faculty. That is called aggregate relationship. That means that one class completely resides inside of the other class. It is indicated by an empty diamonds on the side of the collections. Composition relationship is the strong form of the aggregations, where lifetimes of the classes are matter. So, for example, if we want to destroy a class, when another class is destroyed, then the next its child class will also be destroyed. So this is called the lifetimes. So component cannot be exist without the aggregates. When the parent class or one another super aggregate class is destroyed, then the children aggregate classes will also be destroyed. So it is indicated by solid diamond on the side of the collections. Last one is called the inheritance relationships. Inheritance is in fact the parent and child relationship, where one class is called the super class, also called the parent class, and the another one is called the base class, also called the child class. For example, bird is the part of the mammal, and it is indicated by the triangle pointing to a super class. Now these are different notations we use in the notations for the relationships in the class diagrams. First one called is the associations. So here we use this arrow lines. Another one is called inheritance. Here we use unfilled arrow lines. Another one is called realization or implementation relationships. Here we use the dotted unfilled arrows. And the next one is the dependencies relationships. Here we use dotted arrow lines. And aggregate relationships, here we use the straight lines with the empty diamond symbol in the head of the line. And composition relationship is the relationship where we use the straight lines with the filled diamond symbol on the one side of the straight line. Now dear students, here we will show you the different relationship with the help of the programming concepts. First one is called the binary association. Binary association means that we can access both classes with each other. For example, class A can access B and similarly B can access A. Then it is called the binary relationships. So both entities knows about each other. Then that is called the binary relationship. So for example, here we created my B is the object of the class B, and similarly my A is the object of the class A inside B, and do something is a function A, and operations and services are two different public functions inside of the B. So my B.services, here we can access services function of the B inside of the A, and my A.do something, here we can access the do something function of the A class inside of in the B class. That is called binary association. So originally it may create an association class. Another one is called unary association. Here in the unary association, or it is the only one directional communications. For example, A, B. So here A knows about B, but B cannot knows about A. So B has knows nothing about A. Then it's called the unary association. So in the unary association, we declares the object of class B with the star x, that is the unary association, and do something is the function which is inside A, while services is the function inside B. So here we access my B.services. So my B.services is the function inside of the class B, and it is accessed inside of class A through the object of B. Another one is called aggregate relationship, which is in association with a collection member relations. So here we will provide hollow diamonds on the collection sides. So it is exactly like the unary associations, but only you can see that this is the arrow diamonds. So while do somethings is a function of the class create, and a module.service is an object which accesses the service function of the module class. So here indirectly we are calling the service function of the module inside the create class. Another one relationship is called composition relationship. Composition is the aggregation with the lifetime control is important here. So the part of the object may belongs to only one whole object. So here we provide a certain different sort of the variables and member function inside of the one class. For example, employees has different attributes names and member functions, and similarly team has only the object of the employee class. So and members is in fact the objects here, and members 0 is equal to new employee 0. So that means a new employee is the constructor of the employee class, and member 0 is the first instance of the object. So here if you want to delete member 0, that means that the communications between these two classes will be terminated. So filled diamonds on the side of the collection is used. You can see this is the collection. Collection means multiple instances. And the last one is called the inheritance, which is also called generalization. Inheritance is the parent and child class relationship in which a parent's data members and member function or other piece of code is shared among its children. So for example, A class is the parent here with my x is in variable names, and set x and get x are two different operations, and operation is a function inside of the B. So class B extends A, it means that A becomes the parents of class B. So this is the base class and it is the derived class. Now inheritance has multiple types here. Single inheritance means that only one parent of B is existing here. So you can see A is the parent of B. While multi-level inheritance means that there are multiple levels of inheritance. For example, A is the parent of B, and similarly B is also parent of C. So you can see there are two levels, level 0, level 1 and level 2. So basically there are three levels, but 0 level, 1 level and 2 levels, there are three different levels. Hierarchical interface means that parent A is the parent of three different classes. So it is the hierarchical interface, exactly like the format of the tree. That's why it is called the hierarchical interface. Multiple inheritance means that C is the child of class A and B. This is called the multiple inheritance. Means that C has two different children, A and B. Hybrid inheritance means that, for example, A is the parent of B and C, but B and C is the parent of D. So D has the has multiple sort of the capabilities, like D is the child of B and C, and also D is the indirect child of A. So that's why that is called the hybrid inheritance. Means that D has the hybrid characteristics of A, B, and C. UML has certain multiplicities. Multiplicity means that how many different instances will be created. So multiplicities here are represented through the labels of the 0 to 1 or 0 to static or just static, and 1 or 1 to static labels. For example, multiplicity of 0 and 1 means that 0 or 1 instances of the objects can be created here. So the notation n to m means indicates n to m or many to many instances can be created. 0 to static means that no limits on the number of instances, including none. We can create none or multiple instances. 1 means exactly one instance can be created, and 1 to static means at least one instance can be created. So we can create at least one means one or more than one. Now this is the example of the UML class diagrams of the customers buying systems. For example, customers is a class and with the attributes of name and address, but there are no functions here. And customer is associated with the order class, and order class has date, start, status, calculate text, calculate total, and calculate total weights. These are three different functions inside of the order class. Now this is the association relationship. This is the unary association relation, while this one is the binary association. And order is associated with the payment class, and payment class has only one attribute of the amount. Now amount is the parent of the credit, cash, and check class. Either we can use our credit cards to provide the payment, or cash or the check to perform the payment for the buying. And order detail is the another class with the attributes of quantity and text status, and calculates subtotals and calculates. And this class has a relationship with the order class. So here we have just provided one to many relation between the order and order detail class. And then we have the item class. Item class has two attributes, shipping weight and the description, and also it has the function of get price for quantity and get weights. And this is also a multiplicity of the binary relationship with the order detail class. So here it is the class names, attributes, and the operations. Dear student, this is the end of the lectures. If you have any questions, you can ask through the email. My email is in the footer section of this slides, and the KUST20201.pk. All these informations are taken from these two books. You can study these books for the further information as well. And also, if you want to do the upcoming assignments, you will use these two books for the UML. Thank you very much.